Welcome to Module 7, Quadrilaterals. The two standards we're going to be talking about is I can understand the different types of quadrilaterals and I can apply the properties of quadrilaterals. So these are all the different types of quadrilaterals we're going to talk about. The definitions are right next to it. We have quadrilateral is just a figure with four sides. A parallelogram is a quadrilateral with two pairs of opposite sides parallel. A rectangle is a parallelogram with four right angles. A rhombus is a parallelogram with four congruent sides. And a square is a parallelogram with four congruent angles four right angles and four congruent sides. A trapezoid is one pair of parallel sides. An isosceles trapezoid is one pair of parallel sides and the other two are congruent. And then the kite is a quadrilateral with two pairs of consecutive congruent sides. So another way to look at this is with a flowchart. So if you see, we start with quadrilaterals, and all right next to it is all the theorems that we know that are connected to each figure. I have uploaded a link to this document. It is really helpful to know how they're all connected and what are the different properties of each figure. One thing I want to say about this is that if you go down, it is sometimes true. So a quadrilateral is sometimes a square. A quadrilateral is sometimes a kite. If we go up, it's always true. So a square is always a parallelogram. So a square always has all the properties of a parallelogram as well. So a square has opposite angles congruent. A square has opposite sides congruent, and that type of thing. If you go side to side, it's never. So it's never true. A kite is never a trapezoid. A kite is never a rectangle. So those are not true. The only thing that is the exception to that rule is from a rhombus to a rectangle because they are connected by a square. And since we're going down to connect the rectangle to the rhombus, it's sometimes. So a rhombus to a rectangle is sometimes true. That is the only exception. Otherwise, the rest of those work. So I have this uploaded on a link, so you can download it and look at it and study it if you would like. Okay, so now we're going to talk about a ton of theorems. So the first figure we're going to talk about is a trapezoid. If it's an isosceles trapezoid, then each pair of base angles are congruent. So if you look at the picture, A and D are congruent and B and C are congruent. And then the flip is also true, so the converse. So if you flip the if and then statement. So if the trapezoid has a pair of base angles are congruent, then it's an isosceles trapezoid. So you can have it both ways. Also, if it's an isosceles, then the diagonals are congruent. And the if and only if means that the flip is also true. So if the diagonals are congruent, then it's an isosceles trapezoid. So if we see an example 1 here, you know it's an isosceles trapezoid by these tick marks right here. So if they have tick marks, then you know it's an isosceles trapezoid, so you know the base angles are congruent. So these two are congruent and these two are congruent. So the measure of angle N would be 50. And then L and M are going to be the same. And how we figure that out, so if I look at these two angles, maybe I'll change colors. So if I look at these two, and that is an X up here. So if X and 50, so if you go back to our parallel lines information, and if I look at these two and this, x and 50 are same side interior angles. These two lines are parallel because their tick marks are shown. So x plus 50 equals 180. Because they're supplementary, same side interior angles are supplementary. So then x would be 130. So both of these are 130. So a little bit of prior knowledge there. All right, so then find x in the isosceles trapezoid. So if I look here, I know it's an isosceles trapezoid, so that means that this line is congruent to this line. Well, in order to find that line, the length, all you do is do part plus part. So that means 3x plus 6x minus 5. And then the blue would be 5x plus 2 plus 21. So part plus part equals the whole. And then all you got to do is simplify and do combined like terms. So 9x minus 5 equals 5x plus 23. Alright, so if I subtract 5x, I get 4x. If I add 5, I get 28. 28 divided by 4 is 7. So my x would be 7 in this problem. Alright, so we have one more theorem with trapezoids, and this is the mid-segment theorem. So if there's a mid-segment, first of all, a mid-segment connects two midpoints. So if you see these tick marks here, that means that M is the midpoint of AC and N is the midpoint of BD. You also know that they're parallel. MN is parallel to the two bases. So how you find the lengths is the mid-segment, that's your MN, is the average of your two bases. So you add them up and divide by 2, or add them up and multiply by a half. So in this case, if I put x here, so x equals 1/2, and then 16 plus 9. So 16 plus 9 is 25, and half of 25 is 12.5 inches. So there is my answer. Now you do the same process if you don't have to find the mid segment the same way. You set it up the same way. So you take 20 equals 1/2, and then you have 7x minus 5 plus 17. So now what I would do is I would divide by a half to get rid of that. Dividing by a half, you can do that in your calculator, divide by 0.5, or you know that it's multiplied by 2. So you can multiply by the reciprocal. So that's 40 equals 7x, and then if I combine these two like terms, I would get plus 12. Minus 12. Get 28 equals 7x. I divide by 7, and I get 4. And that is what x is. So mid-segment is what you always start with, equals 1/2, and then you add up your two bases. Alright, so now let's moving on to a kite. If you know it's a kite, then the diagonals are perpendicular, which means that they form right angles. Also, if it's a kite, then exactly one pair of opposite angles are congruent. So if you see the picture, it's C and A. So it's the ones where two of the non-congruent sides meet. So it says QRST is a kite, find the measure of angle T. So this is what I want to find is X. Now if I look at the picture, T is the same as R, so I know that this is also X. So now if I remember, all angles of a quadrilateral add up to 360. So I can just do, whoops, not a 2, x plus 88 plus 70 equals 360. And I can solve that problem. 88 plus 70, so 2x plus 150 equals 360. So this is what measure of angle T. And actually I probably should not put X. I should probably put the measure of angle T equals 105 degrees to make my statement correct. Alright, so now this one, it says find the measure of angle K. So this one, I need to find this angle, which is my X. Now I need to figure out what I is. Well, if I look, if E is 90, then I is 90. So I'm going to do the same thing. So X plus 90 plus 90 plus 107 equals 360. And this one's, oops, not plus. So 180 plus 107 is 287. Equals 360, and then I subtract 360 from that answer, and I get my X. So that is the measure of angle K. There we go. All right, now we're on to parallelograms, the middle section of your flowchart. Parallelograms have opposite sides congruent. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And then the diagonals bisect each other. So those are your 4 theorems we're going to be using to solve these problems. So first, here's a side. So if I know x plus 6 there is going to be the same as 13 because opposite sides are congruent. X plus 6 equals 13. So minus 7. So that would give you, so there's my x. Now I have to find my y. Well, just like opposite sides are congruent, opposite angles are congruent. So y is 68 degrees. So if you know your theorems, these problems become very simple. But you got to know your theorems. So see if you can remember and how to figure out this one, and then we'll talk about it. Okay, so y is 123 degrees because opposite angles are congruent. I did 37 equals 2x minus 3 because opposite sides are congruent. And I solved to get x is 20. And then I know that consecutive angles are supplementary. So if they're right next to each other, like z and 123 are, then I can add them up to 180, and I get 57. All right, so here also, I know that the diagonals bisect each other. That was our last theorem. So that means that these two are congruent and these two are congruent. So x is 9 and y is 8. So we just have to make sure that they're on the same line. So this right here is being cut in half. And this one right here is being cut in half. So, same process. This one and this one are being cut in half. So that's how we solve. 2y minus 1 equals 9. 2y would equal 10. So y is 5. And then x plus 3 equals 12. So then x minus 3 would be 9. So if you know your theorems, these problems are simple, but the tricky part is remembering all those theorems. All right, so here is a parallelogram. This is a symbol for a parallelogram. So it says I want to find all these different measures. So I'm given some information on my picture, and I want to find NM. So this is NM. Well, if we just talked about the two diagonals being cut in half, so that would be 2. KM would be the whole length, so that would be 4. JM is a side, so I know that opposite sides are congruent, 9.5. And then it says JK. Well, opposite sides are congruent, so that would be 11. The measure of JML, JM to L. So this is our angle that we want to find. This whole angle, well, consecutive angles are supplementary. So 110 plus x gives me 180. So x would give me 70. So that's 70. And KML, well, if this bottom one is 30 and the whole thing is 70, the top one has to be, 40. So let me see if I can highlight that for you. KML. So if I look, this half is 30, so then if the whole thing is going to be 70, then the top has to be 40. And then KML, KLM, sorry. So then this would be this angle, the whole angle here, while opposite angles are congruent, so that means that that would be 110. So it gets a little messy when you're putting all these tick marks and putting everything in, but just doing one at a time and trying to look at that helps. All right, so that was a more complicated problem. And then we have a few more theorems, and I know there's a lot in this unit. So a rhombus has diagonals are perpendicular. We have a rhombus has diagonals bisect opposite angles. And then a rectangle is diagonals are congruent. So we have a couple for rhombus and one for a rectangle. And this is the last problem. So this is a rhombus. So use those rhombus theorems, and remember every other theorem for a parallelogram also works. So everything that we just talked about also works. So I wanted to see if you can find all these different things. Try some on your own. When you get stuck, then play the video back and we will go over it. All right, I'm going to talk through the first 5 and then we'll do the last 2 together because the last 2 is a little tricky. So the first one, if I look at my angles, the previous theorem said that the angles were being bisected. So I know that that red highlighted angle is also 34. And how we name angles, remember, is you just do connect the dots. The middle one is always your vertex, and then you connect W to Z to V. The next one is the middle angle. V is your vertex, and so you know that the diagonals are perpendicular, so that means that it would be 90. And then the green angle would be XYZ, would be 112, because if both parts are 34, the total angle Z is 68, and 68 plus X is going to be 180. And then I minus 68 and I get 112. If you see the diagonals are also being bisected, So I know that these two, WV and VY, are congruent. So WY is going to be 14. X, the angle up at the top has a vertex of X, Y, X, Z is your yellow up at the top. And if the bottom is 34 and 34, then the top is also 34 and 34. So that would be 34. Now, I highlighted the yellow triangle, and I drew it out here. Top angle is 34. The XY is going to be my X, and my XV is going to be my Y. And I know my 7 is going to be the other angle. And how we solve this is by trig. And I know we may not remember that, but this is my opposite, this is my hypotenuse, and this is my adjacent. So my first one I'm going to solve for is my x. So that's my O and H, so that's going to be my sine of 34 over 1 equals 7 over x. And I cross multiply x times the sine of 34 equals 7. So then I get x equals 7 divided by sine of 34, and I get 12.518. And that is going to be 12.518 there. So now for my next one is A and O. So this is still my opposite, this is still my adjacent. But to solve, I'm going to use tangent, because A and O is tangent. Over here. Tangent of 34 over 1 equals my 7 over y. Y times the tangent of 34 equals 7, so then y, I do 7 divided by the tangent of 34 this time, and I get 10.378. And that would be the last one, 10.378. So those last two are a little bit trickier because you had to use trig and know that it was a right triangle. But all the others, if you knew your theorems, they weren't so bad. All right, now you got to practice. Good luck.